In this video, I'm going to show you how to do proving by mathematical induction, in short PMI, involving inequalities. We start off by writing out this statement as a proposition, so stand with letter P. Proposition means a statement yet to be determined. It can be true or false. So P, propositions, in terms of n, where 3 to the power of n is greater than n squared plus 2n, where n is greater or equal than 2 and n is an integer. So this is the original statement, followed by a basic step. A basic step is you plug in any value that is greater than 2 or equal to 2, to prove that this statement is correct. So it can be 2, 3, 4, 5, 6, any number that you want to. But for my own preference, I always like to start off with the first term, which is 2. So the basic step is to do a check whether this statement is correct. So when n equals to 2, on the left hand side, 3 squared, you replace n with 2, that will be 9. On the right hand side, replace the n with 2, that will be 8. 9 is greater than 8, left hand side is greater than right hand side. This is correct when n equals to 2, right? So left hand side equal to right hand side when n equals to 2. So it's correct. So for the first term, this is correct. This is true. Okay? This is the first thing that you have to know. Now I'm going to erase all these things. So you have proven it. This is the first step. Okay, there's just too many of them. There's no way that you can plug in n equals to 2 and 3 and 4 and 6. There's just too many of them. So that's where the idea of induction came in. So what we do is we assume true, which is correct, when n equals to k. K can be any number, any terms, as long as it's more than or equal to 2. Okay, it can be any term, just unknown k. So we assume that it's correct. What do we do? Just replace the n with k. So you might be confusing. What do we do with this? Let's have a look. Okay, you just have to replace all the n with k and that's it. We don't do anything about it. Since we assume that it's correct, that's not where your working step. Your working step should be emphasize on the next parts. Okay, we assume that this is correct. So what we do is we're going to prove that the next term require to prove. Okay, we're going to prove the next term is correct as well. What is the next term after k for any integer? Think. Next term after k for integer. It will be k plus 1. That's right. So we're going to replace k with k plus 1. We're going to replace k with k plus 1 and yep, there you go. So this is what you need to prove later on. Can we simplify this? Right, we could. So let's simplify it. Okay, so that's what you need to prove later on. Okay, this is your ultimate goal. You need to prove this later on. But there's just no way to prove. There's just too many of unknowns, right? Okay, so how do we prove by induction is, we're going to use this statement that we assume that is correct to arrive at the final statement. That is induction. Okay, you must use this as the starting step, basic step, and you must arrive at this. So this is induction. So what do we do is, let's start with this, that we assume that it's correct. Since it's correct, we can use it. Okay, we start with something that is true. How do we turn this to this? 3 to the power of k to 3 to the power of k plus 1. How do we turn it to be the same? We multiply by 3. Right? You remember the index law, right? So when we multiply by 3, do I change the sign? Do I flip the sign? No, because you multiply something that is positive, you won't change any of the sign. So we have k plus 1 now, because this is power of 1. So when you multiply the same base, you have to add up the power. 1 plus k, which is k plus 1. And then 3k squared plus 6k. Okay, this is the part that is a bit difficult to understand. Okay, now I want to do assumptions. I want to do an assumption that, okay, let's call this the blue color. I want to do an assumption that the blue color is greater than the green color. Yeah, I just do an assumption. The blue one is greater than the green one. So if I do the assumptions, I will have 3k squared plus 6k greater than k squared plus 4k plus 3. Yes, I'm doing assumptions. Okay, so I'm doing the assumption that the blue one is greater than the green one. So when I do it and I simplify it, I want to see whether it's correct. Okay, is this correct? Is it correct? How do we know it's correct or not? Remember, there are certain criteria. Your k must be greater or equal than 2, equal to 2. So if you plug in 2 here, is your left hand side greater than 3? Yes. If you plug in 3 on your left hand side, it will be always greater than 3. And you try with n equals to 4, it will be greater than 3. So think about it. If you sub in 2, 3, 4, 5, any number that is greater than 2, this is always correct. Am I right? Am I making sense so far? As long as your k is equal or greater than 2. Make sense? So this is correct, right? Hence, this is also correct. So let me circle it. Let me put a tick. So this is correct. We have proven it. This is correct. The blue is greater than the green. The blue is greater than the green. Okay. And we also know that we have proven that just now from here to here, from here to here, we have proven that, let's call it as brown. The brown is greater than the blue. Right? This is also correct because we start with something that we assume that is correct. So this is also correct. Then this is the part. Okay, you see, brown is greater than the blue. The blue is greater than the green. Is it true that I can say or I can conclude that then the brown must be greater than the green? Am I making sense? It's correct, right? All right, so we can conclude that by, okay, maybe you don't have to say that. You just have to put a dot, 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 dot. So the blue is greater than the green color parts. Okay, so now you have proven that this is correct. This is what you require to prove, right? So you have proven that this is correct. So you have proven that when n equals to k, it is correct. When n equals to k plus 1, it's also correct. So k and k plus 1 is always true. Am I right? And k plus 1 is just 2 consecutive terms. And these 2 consecutive terms can be the first term and the second term. Can be the second term and the third term. Can be the third term and the fourth term. Basically, any 2 consecutive terms. Am I right? Since you have proven that the first term is correct, if k is the first term and first term is correct, then the second term must be correct. If second term is correct, then the third term must be correct. So that is the idea of induction. Hence, every term is correct as long as your n is greater than 2. That's the idea. So the final conclusion by PMI, proved by mathematical inductions, the proposition of n is true for n greater than or equal to 2, where n is an integer. That's it. That's the idea of PMI.